All right, welcome everybody. We're excited to have you at the Semantic Exchange webinar today. We're going to give people another minute or so to join before we get started here, just so people can settle in, and then we'll dive right in. All right, we've still got people rolling in here. We're going to give everyone a moment to join, get settled in. All right. Well, thanks everyone again for joining us today. This is the fifth installment of, I guess, this series of the Semantic Exchange webinar. We did another series in fall of last year, so this has been another fun addition to that. The Semantic Exchange webinar is a Ask the Expert sort of series, so you get a chance to hear directly from EK's thought leaders. Today we're hearing from Diana Felder, and you get to ask questions about their recent pieces of thought leadership. So it's a fun way to interact, get your specific questions answered, and really just have a conversation in the semantic space, which is always a fun thing to do. A little bit about Enterprise Knowledge. We are a knowledge management consultancy. We're based in the Virginia, DC area, and we focus on knowledge management as well as, of course, semantics. So we have a great crew of taxonomists and ontologists, as well as graph engineers and AI engineers, doing this exciting work for different clients across different domains and industries, and supporting different solutions as well. So we've got some great expertise and experience in the space, and are really excited to share that with you. I am Sarah Mae O'Brien Scott. I am a principal consultant at Enterprise Knowledge, and I'll be the moderator today. We will ask that if you have questions, you just input them into the question feature here in Zoom, and we'll be monitoring those. Before we get too far into questions, Diana will have a chance to go through and just talk about some of the high-level points from her piece. Today, we're talking about ontology and knowledge graph in the age of generative AI. And this piece is pretty well hot off the presses, so hopefully you've had a chance to read and come with your questions. All right, so with that all said, we'll pass it over to Diana to give us a brief overview, and then we'll get into the Q&A.
So thanks, Sarah Mae, and thanks to everybody who's here today or watching later. The topic today is on ontology and knowledge graph in the age of generative AI and agents. And I'll start just by giving a brief overview of what an ontology is. I suspect a lot of people who are here probably already know all of this, but an ontology is essentially a map of a knowledge domain that identifies the kinds of entities that exist in that domain, the properties that those entities can have, how those different entities can relate to one another, and in more advanced ontologies, the logical rules that govern the connections between the entities. And ontologies are made of classes. These are like categories or types of things in the domain. Attributes, which are the properties of those entities, things like names or dates, and then the relationships that hold between members of classes, the entities in the domain. And so we, have an example here of a snippet of an ontology covering information about purchase orders. There's classes like purchase order and customer and product relations, like purchase orders are placed by customers, and attributes like dates on which the purchase order occurs. Now, ontologies are, and we'll get into this in a second, but they're only one piece of the semantic layer. But even by themselves, they can be useful for enhancing your AI applications or your agentic system. So one of the things we're seeing pretty frequently with systems based around large language models is that these models are trained on publicly available information. That's, lots of websites, Reddit, etc. But as a result, the answers that these systems give tend to come from a more general, publicly available perspective, not from the perspective of not of the particular business, right? Each business has their own kind of way of looking at things, their own conceptualization of their data, their information, their processes. And as a result, the large language models can um, misunderstand key concepts because they're not seeing them through a particular business's lens. Ontologies in and of themselves can be useful here because they are built around a business's proprietary or particular understanding of the concepts that are relevant to that business. And so you can supplement the prompts that you send in an AI application or in your agentic workflows with pieces of the ontology, particularly definitions, but even facts about the relationships you're expecting to hold between entities or whatever. And by providing that additional context to the LLM, you help to align the LLM's responses with your organization's specific definitions, its specific understanding of the domain. And this actually allows you to, this scales across agentic systems, because if you have a single ontology covering your domain and all of the different AI applications and agents are calling on that ontology for additional context, then you're getting the same context across all of those applications. So as I said earlier, ontologies are only one piece of the semantic layer puzzle. The other big piece of the puzzle is knowledge graphs. And ontologies are, they're abstract schemas, they're abstract maps, as I said, of a domain. But the knowledge graph actually takes that ontology and applies it to particular specific data. So instead of talking about abstract classes like purchase order, we're talking about particular purchase orders with IDs in data. And the knowledge graph is structured, constrained, designed to fit within the ontology. Knowledge graphs are linked. They connect entities across data sets, and that's important for using them to enhance your AI applications. They can be queried in a number of different ways, the direct Sparkle, you can build APIs to talk to them, and agents can use model context protocols to access knowledge graphs. And knowledge graphs are also potentially self-enriching. So with those rules I mentioned earlier, you can actually derive new facts about your data deterministically from existing data and logical rules. So, there's often a lot of talk about ontologies and knowledge graphs, but the core difference between them is that an ontology isn't data. It's a schema of meaning for a domain. The knowledge graph is the actual real data that is governed by that ontology's schema. Uh, so knowledge graphs, ontology plus all of the data together have even greater benefits for aligning AI and enhancing your AI applications. A lot of the work that's being done today in agentic systems uses RAG, and most of it is what we call standard RAG, which involves retrieving chunks of text based on similarity scores from documentation and using that to supplement LLM prompts. This approach is very helpful. It helps to align the LLM, but it has its problems. The information that you retrieve is very fragmented. Similarity scores can't identify the links that you need between things. So if you're looking for European suppliers who I want to know which European suppliers are in violation of compliance rules, right? You're going to get facts about compliance rules. You might get facts about European suppliers, but you're not going to actually get that link between the two pieces of information that you're looking for. Graph RAG, on the other hand, is retrieval augmented generation that relies on a knowledge graph. It retrieves from a knowledge graph, and hence it benefits from all of the linking that is found within the knowledge graph. So it retrieves that semantically structured data, and it, as a result, can access data that across different data sets that has been linked through the knowledge graph. Because the graph is structured via the ontology, that ontology can be used to disambiguate meanings between terms. So um, uh, terms that have different potential meanings, they have set meanings in the ontology, and so you know you're grabbing the right one. And because of the linking, you can actually traverse conceptual relationships. You can get that answer of which European suppliers are in violation of compliance rules, because all of the data is already linked in the knowledge graph. Um, so by using ontologies and knowledge graphs to supplement your AI applications and your agentic systems, you get a number of different benefits. Responses are more accurate because you're pulling the right information at the right time. And it's grounded in your particular business's understanding of the concepts in the domain. You get greater consistency across your applications because they're all relying on that same semantic foundation, those same meanings. You get more ability to traverse conceptual relationships, to actually identify and utilize the links between information, which gives the AI more power to actually reason deeply or more deeply about the information that it's using. And it also can reduce costs because instead of retrieving irrelevant information to your query, you're retrieving exactly the information from the graph that you need, and that reduces the overall token costs. Um, and that's a brief overview, and now I think we'll open it for questions.
That's great, Diana. Thank you for going through that. I think many of us are trying to figure out what fits where in the age of AI, what makes sense to where spend our time and investments in, and this is helpful. Um, One question I think would be helpful to dive into more. So you introduced ontology injection versus graph rag. Can you talk a little bit more about when an organization should use one versus the other? And while Diana is answering that question, please feel free to drop in any other questions, participants that you have that you want to make sure you get a chance to chat with Diana about today.
So I would say that the choice to use ontology injection as opposed to graph rag really depends on the kind of information that you want to be feeding to the large language model. If it's about if it's high level conceptual information, if it's definitions, you want the LLM to align with what you mean by a compliance agreement or something like that. Then ontology injection is probably where you want to focus because that's the main benefit that you're going to get out of ontology injection. If you need to uh, reference actual data, if you need actual facts about particular entities in your data domain, then graph rag is probably the way you're going to want to go.
Great, that's really helpful. Um, we have a question from an anonymous attendee. Do you utilize or see value in formal upper ontologies such as BFO? What are your thoughts there, Diana?
So I recently authored another blog piece about this exact topic with James Egan. So I will self-plug and encourage you to check that out on the Enterprise Knowledge website. But I do see value in upper ontologies such as BFO or even if you don't want to go that high, core ontologies, which you can adapt from BFO or GIST or Dolce, or even build yourself, can be extremely useful in um, aligning all of the different domain ontologies that you need to cover your various applications. They build consistency across your entire semantic layer, and they enable greater sort of constraints on constraints maybe isn't the right word, but they enable smoother, more streamlined development of lower level ontologies. Uh,
Mm-hmm.
that that said, I think it can really depend on the use case that you have, the with respect to how high you want to go in terms of those top ontologies. And I know some of the more publicly available standards can sometimes be a little bit difficult to deal with. But that in general, having an upper ontology or a core ontology that orchestrates all of your lower ontologies is often a really good idea.
Great. Thank you, Diana. Um, Another question here is in terms of understanding if you're going in the right direction, if you've gotten things right. So, is there some type of testing that can be done to know if AI solutions will benefit from an ontology to an extent where the expenditure of resources is worth it to build one? We know, it takes time to build an ontology. It's not nothing to go into that effort. So, how do we know that it's worth it, that it's actually benefiting my AI solution?
So I think there are a number of factors that can help indicate that you're likely to benefit from an AI, from adding semantics to your AI solution. Um, if you are in highly regulated spaces where accuracy and traceability is really important, that can be a consideration with uh, graph rag and ontology injection. You are aligning the LLM better to the definitions that you have, and hence you get greater accuracy. If you're seeing problems with a lack of connection in the answers that you're getting, if you're seeing that you're asking questions of your AI application and it just can't draw links between the data, that would be a good indication that it would be useful to look into this. In terms of like a simple test that you can do, um, you can actually kind of come up with like a proto, like just a very draft proto ontology, um, not even a whole ontology, just snippets of one, and you can compare when I ask without this versus when I ask with this piece. Am I getting better answers? Am I using fewer tokens? And if you are, then that is an indication that you should look into it.
Yeah, that's really helpful. I know at EK we've done several projects or POCs where we have A/B tests to demonstrate whether to move forward with semantics, especially ontology, in a AI solution. So we'll build an interface that really clearly shows, this is side A that does not have semantics as part of the solution. This is side B. And as you input the same question, you can compare the answers based on different metrics on things like completeness or coverage, correctness, accuracy. Those are some of the things that we're looking for quite often. That's great. Um, oh, let's see. We have a question from Angel. Let's see. How do you make the case to a client who already has a flat RAG system that's good enough? What's the quantitative argument for semantic structure? And Angel followed up and said, I think you just answered my question, but curious, Diana, if you had any other thoughts you wanted to add there.
Oh, do I have it? So I think I kind of touched on some of the way you can make the case. I think the additional case that could be made is definitely, if I haven't already mentioned it, token reduction. I think companies are having ballooning AI costs right now, and people are token maxing and using as many tokens as they possibly can. And standard RAG eats up a lot of tokens. Often, if you, depending on how you set your similarity scores, you might get very large chunks of text, much of which is irrelevant. Every few words, right, is another token that you're paying money for. And so I think one way I would make the case is in terms of uh, the ability of a graph RAG um, application to I draw out just the most relevant piece of information that's necessary for the LLM to answer the question, or at least significantly more relevant at significantly lower token cost.
Hmm. Yeah, I think that's pretty compelling. Another thing that I see with our clients is whether it's worth it, whether they should move forward with a semantic structure versus just a flat RAG, as Angel is saying, depends a lot on the use case itself. So if your use case or your knowledge assets are more generalized kind of knowledge that the LLM might be familiar with, that might be enough. The LLM might have enough context already that it's able to really handle your competency questions or use cases. But if you are working with really specialized knowledge that's very specific to your organization, very unique, bespoke, that might be a time when you're considering infusing knowledge models in different ways into your AI solution because LLMs just don't necessarily have that context that's more specialized.
And I will say that in some cases, you don't actually always have to utilize a full graph of the domain itself. Sometimes you can build a graph that is dedicated to just identifying um, that essentially that treats your documents as the entities. And that helps organize, categorize, and relate all of the metadata there, so that that is sometimes a not as heavy of a lift, but still can supplement. Uh,
Oh, great. Well, Angel follows up to say token optimization is a hot topic right now. Love that answer. Thank you. Thanks, Angel. Um, we have another question from Casey. Casey says, do you have any tools you recommend for trying RAG? Is it as simple as me uploading a turtle file to an LLM to put it in the context window?
um, this definitely varies from application to application and use case to use case. The architecture is often a little bit more involved than that, and um, uh, kind of depends on your individual business's structure. If you already have agents that are operating with a model context protocol, that can be built to access your knowledge graph easily that way. In some cases, you can I design agents to specifically write particular SQL queries and draw that information back that way. Um, for testing, sometimes yeah, just drop some TTL in the context window with whatever prompt you're working with and see if that works.
Great. Thank you, Diana. Um, let's see. You just kind of mentioned you've been mentioning agents here and there throughout this session. Can you talk a little bit more about how AI agents interact with the graph? Um, I think there's Sparkle APIs, MCP servers. Those are a few things that you mentioned. What are those interactions with agents looking like in particular?
Agents are pretty cool in that they can basically perform tasks in a variety of different ways. You can build them out to do all sorts of different tasks. So as I mentioned before, one of the ways that this works is agents are provided with like Sparkle query templates that can be, filled in from the query context. And thereby reach out to the graph and retrieve the particular information that you need. Um, in other cases, they, access specific APIs, and so the agent will have to be tailored to understand the structure of the information that's coming back from that API and plug it back into its own into the context of the task that it's performing. Model context protocols are. I will admit that this is a place where I am not as well versed, but my understanding is that there are already model context protocols that are built that basically provide a standardized way for agents to interact, uh, to reach out to graphs and pull back more information. One really cool way that I have seen this in the past, though it's very sort of cutting edge, is actually getting agents to write their own specific Sparkle to access the graph, based on the particular query that has been asked and maybe some patterns that help identify what's already in the graph. But that is kind of an advanced case.
Mhm. Thanks, Diana. Okay, I think we have time for about one more question. Let's see, Casey is saying, thanks so much for your previous answer. This has been great. Thank you, Casey. Second question, if time permits, and I think it does. This started with folks already using LLMs, and then we consider augmenting that with Ontology's graphs. But how often do you find at EK that folks should replace their LLM structure and go with a more pure graph structure? Are there some signs in clients you look out for?
In this current moment, where I would actually love to hear Sarah say more about this after I give my answer. In this current moment, I don't think we're seeing a lot of clients who are replacing their LLM structures with pure graph. The LLMs agents are the hot new thing that everybody is looking to try and exploring the benefits that we can get out of those tools. And so I personally haven't seen a lot of move in that direction. I've actually seen more move in the opposite direction. People really trying to build out their agentic systems and find ways to make them more accurate and less expensive.
Yeah, I would say that's right. That's certainly what I've seen also, Diana. I think it is worth considering. Sometimes there's an assumption, especially as AI has become, the all-encompassing topic that it is, that all AI is generative AI, and that, we know that that's not the case. So there is a need to kind of step back and say, is generative AI or LLMs actually what I need for this particular use case, or are there other routes that I should take that are, more in the analytics space, or other types of areas where we're using AI. So that's
And I,
that's a bit of the conversation that I think has been lost in the last year or so. But I don't see that people are really pursuing that as hotly as they're trying to understand how to use the powerful LLMs that we have.
I I I 100% agree with that. I do think it's important, especially for people in the semantic space, to remember that not all AI is Gen AI. Some AI is actually rooted very firmly in semantics already. Um, I do think that I think certain organizations are probably less comfortable, especially in like financial or healthcare spaces where there's a bit more regulation with pushing AI, and so might be more amenable to pure semantic solutions because they are deterministic. Um, so that may be a place where there's uh, you could potentially push for, and like because of your compliance requirements, all of the regulation, you should really use a full graph solution in this particular use case in this industry space.
That makes sense. Well, we are at our time for today. Diana, thank you so much for joining us and being our expert of the day. That was a great piece that you wrote. We'll also encourage people to check out the one that you wrote on upper ontologies with James. Thank you all for participating. Really appreciated the questions that we had today. It was a lot of fun to have this discussion. And as I mentioned, this is the last episode in this series, but look out for future series with the semantic exchange coming up later this year, as we'll gather some more experts for these kinds of conversations. All right. Well, we'll be sending out the recording later on. In the meantime, everyone have a great day and take care.